All right, so now we're faced with this triangle. We have a right triangle. We're being told that because it has this squared off piece in the corner here. We know then that B is our right angle. That tells us then that 13 is our hypotenuse. So that's something that we can note right away. We can't identify whether 5 or 12 is the opposite or the adjacent yet because we don't know which angle we're referring to until we get to the questions. So it all depends on which one we are calling the angle measure. So to fill out this column here, we're going to be looking at angle A, and we're going to remember that we're talking about our nice little reminder here of what our ratios are. Okay, so when we're talking about sine, we're going to pick the opposite of the angle and divide it by the hypotenuse. So if my angle is A, oopsie, that means then that this is the angle I'm looking at. So I need the opposite of that angle, and that would be the 12. And I'm going to divide that 12 by the hypotenuse, which is the 13. If I'm looking for the cosine of angle A, cosine needs the adjacent side. Adjacent is the side that's touching, so that's the 5. So we'll do the 5, and we'll divide that by the hypotenuse, which is 13. When we're looking for the tangent, we want to figure out the opposite side and the adjacent side. So the way that I identified the opposite side is 12, and my adjacent side is 5. Now we could get the decimals for those, and that would give us what the ratio of those two sides, or the hypotenuse and the side, are to each other. When we change gears and we are looking actually at angle C, so this is angle C down here, right? That's going to change which one of these is my opposite side and which one of these is my adjacent side. But it won't change the hypotenuse. The hypotenuse stays the same for the right triangle the whole time we're working with it. So for the sine of C, I want the opposite of C. So I go all the way across and I see the opposite is 5. And I'm going to divide that by the hypotenuse. Well, the hypotenuse stays at 13. You'll see that the sine of C is different than the sine of A because we're talking about two different angles. Then when I go to find the cosine, I need its adjacent side. So its side that's touching is the adjacent side. So that's going to be 12. And I'm going to divide it by the hypotenuse. And when I go to do the tangent, I need the opposite side divided by the adjacent side. So looking at C, the opposite side is 5. The adjacent side is 12. So it would be 5 divided by 12. Now, if you look at the relationship between these two, hopefully you notice that the sine of one of the angles is actually the same as the cosine of the other. The cosine of one angle is the same as the sine of the other. And for the tangent of the two angles are just reciprocals of each other. It's a good thing to notice as you're going through something like that, is to see if you see any patterns. All right, so next we're going to look at how to do this in the calculator, and that's why I have my Desmos pulled up to the side. So real quick, take note. It says round to the nearest thousandths place. So we know we need 3 decimal places. So we're going to just type these in our calculator, type them in Desmos. The first thing we have to do is we have to make sure that our calculator is set on degrees. And that is for Desmos as well as handheld calculators. Also your phone. Okay, if you're using your phone calculator, you need to make sure it's set on degrees because there's multiple ways to measure angles, multiple units. Just like there's inches and centimeters, there's multiple units for angle measures. So I'm going to come up here to this little wrench for my graph settings, and I'm going to make sure that I am set for degrees down here at the bottom. You'll see it has radians. I don't want radians. That's a different form of measurement. We'll get to that later. I want it set on degrees. So you have to make sure that is changed before you use this. Okay, and I'm looking for the tangent of 64 degrees. Well, the way I'm going to get tangent is I'm going to go under this functions button here. It's actually going to be under the trig title. And you'll notice we have sine, cosine, and tangent. We're going to use those. We're also going to get to a point where we use the inverse sine, the inverse cosine, and the inverse tangent. So the first one is asking for the tangent. So I just hit tangent of 64 degrees. I close my parentheses, and I'm taking that to the nearest thousandth. So that's 2.050. Okay, now I'm going to take the sine of 64 degrees. So I go up to functions under trig, and I do sine, and I put in 64 degrees. Once I'm set on degrees in my settings, it stays there until I change it, or until I close it and bring up Desmos again. I might have to change it every time I bring up Desmos. So I have the sine of 64 degrees, and that gives me 0.89, and that 7 is going to bump that 8 up to a 9, so 0.899. And then the last one I'm going to find is the cosine of 64 degrees. And that one gets me 0.438. And after the 8 is a 3, so the 8 stays as an 8. Okay, so that's how you could use your calculator to find actual ratios, sine, cosine, and tangent. Okay. So what we're going to do is we're going to apply SOHCAHTOA. We're going to set up equations to be able to solve for missing parts of triangles. So the first thing, it was not marked on here, but we're going to make sure it gets marked. I'm going to tell you right now that this is a right triangle and that this is a right triangle. We cannot make that assumption. We have to be told that. And so I'm telling you that this is a right triangle. The other thing you want to do is you want to figure out which angle that you're referencing. Sometimes we're given the angle measure, okay, and sometimes that's actually what we're looking for. In this case, we're given the angle measure. And we have 48 as one of our sides, and we have x as our hypotenuse. Okay, so looking at this angle measure, 48 is actually going to be the opposite side to the 25 degrees, and x is the hypotenuse. So when I try to figure out which ratio I want to use, SOHCAHTOA, what I want to do is I want to find one that uses the opposite and the hypotenuse. And that ends up being our sine function. So I go ahead and I write my ratio. I say that the sine, and I put my angle measure in, 25 degrees, is equal to the opposite side, which is 48, divided by the hypotenuse, which is x. And now it's just a matter of solving using algebra to get x by itself. The first thing I want to do, though, is get this x out of the denominator. So I'm actually going to multiply both sides by x as my first step. So I get x times the sine of 25 degrees equals 48. And then I can divide both sides by the sine of 25. And that will actually be what I put in the calculator to find my answer. So 48 divided by the sine of 25 degrees is going to give me the length of x. So I'm going to type that in, 48 divided by, I'm going to go to functions, sine of 25 degrees, and I'm getting that hypotenuse is 113. It didn't give me a rounding thing, but I'm going to put 0.6. Okay, and I can put inches on that. I know it's inches because the other one was in inches as well. All right, to solve the second one here, again, identify which angle you have. Looks like I have this 40-degree angle here. Now, with respect to that 40-degree angle, what are the pieces? Well, this side seems to be attached to the 45 degrees, so that's the adjacent side. And this piece here is actually opposite the 90-degree, so that's my hypotenuse. So I want to go and check out and figure out which one of these relationships uses the adjacent side and the hypotenuse. And that's going to tell me which trig ratio to use. And cosine has the adjacent divided by the hypotenuse. So I'm going to say that the cosine of 40 degrees equals the adjacent side divided by the hypotenuse, which is 25. All right, so I'm going to follow some solving steps here, and I'm going to multiply both sides by 25. So what that gets me is 25 times the cosine of 40 degrees equals x, because those 25s would cancel. So that's just what I'm going to type in my calculator. 25 times the cosine of 40 degrees. And I hit enter. And I get that that side length is going to be 19.2, and I'm dealing with centimeters on this one. Now, this one was pretty easy to solve because x was in the numerator. Over here, when we had x in the denominator, there was multiple ways you could have approached this, okay? You could have done cross multiplication and identified that there was a 1 in this bottom. Some people like to do it that way. Another way that I have solved this when x is in the denominator is I just reciprocate both sides. So this would be 1 over the sine of 25 and x over 48. As long as I do that operation to both sides, it's fine, okay? So, but the very first thing you do have to do is get the x out of the denominator, because the only way you can solve is if it's not in the denominator. All right, so that's going to end this video because of my time constraint. We'll pick up with the next one.